You're welcome to Excellent Simplified Tutorials.
Right. Okay, so we'll be talking about nucleotide metabolism. Nucleotide metabolism. And we all know that we have four main macromolecules, right? Nucleic acid, lipid, protein, and what? And carbohydrates. Now, nucleic acid is one of the macromolecules. And the building block of nucleic acid is what? Nucleotides, right? Now, we're going to look at how the nucleotides are metabolized. So if you join one nucleotide to another nucleotide to another nucleotide like that, we have our what? Our nucleic acid. Good. Now this nucleotide is composed of three things. If these three things are not there, it is not a nucleotide. So the three things that make up the nucleotide are the what? Nitrogenous bases, Pentos, and what? Phosphate group. So these three things must be there. Nitrogenous bases, Pentos, phosphate group. The Pentos is the sugar here. So now, if the phosphate group is not there, it is called the what? Nucleoside. So nucleotide contains nitrogenous base, Pentos, and phosphate. If we keep the phosphate group aside, we call it a what? A nucleoside. Why? Because we've kept the phosphate group aside. So you call it a nucleoside. Good. Now, so nucleoside contains only nitrogenous bases and what? And Pentos, right? Only nitrogenous bases and Pentos. Do you understand?
Yes.
You know the rhyme I gave the other time that most of you are now using. That you are the phosphates in my nucleotide. Without you, I'm just a nucleoside. Because without phosphate here in the nucleotide, you become a nucleoside, is it not?
Yes.
Good. Don't write it down, please. Alright, so this nitrogenous base can either be a purine or a pyrimidine. A purine or a pyrimidine. That's the nitrogenous base now. Nitrogenous base can either be a purine or a pyrimidine. Now, when we talk about purine are fused rings. Two rings fused together. While pyrimidines are single rings, just one ring. A six-membered ring. Now, examples of purines are adenine, guanine, hypoxanthine, and xanthine. Though these are the two main found in our nucleic acid, but we have two other ones which are intermediates in biosynthesis pathway. So adenine, if you don't call it adenine, you call it 6-aminopurine. We'll see why. Now guanine, 2-amino 6-oxypurine. Hypoxanthine, 6-oxypurine, and xanthine is what? 2,6-dioxypurine. Good. Now, for our purine here, now look at adenine. Look at the structure of adenine. We said adenine is what? 6-aminopurine, right? Now this is the reason. If you are numbering this ring, so this is our nitrogen 1, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. So you see that the amino group is on carbon 6. That's why we say 6-aminopurine. That's why we call adenine 6-aminopurine. I'll show you a simple way to draw this stuff. But for now, just understand how it is. Now, for our guanine, we call it what? 2-amino 6-oxypurine. Because if you number it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the amino group is on carbon 2, right? So we said 2-amino 6-oxypurine. That is our guanine. Then our hypoxanthine, we say 6-oxypurine, right? Because the oxy is on carbon 6, so we call it 6-oxypurine. For our xanthine, this carbon what? This 1, 2, this 2 and 6, right? That's why we call it 2,6-dioxypurine. Good. So that's that for the purine. If they ask you the other name, is as simple as knowing their structures. Now, for the pyrimidine, we said pyrimidines are single rings, right? Just one ring is not fused. If you look at this one, two rings are fused together. Now, the pyrimidines, you can use CUT. Though we have a minor one here, CUT, CUT. So we have uracil, we have thymine, we have cytosine, we have orotic acid. Orotic acid is an intermediate These are the main three found in nucleic acid. So uracil is also called 2,4-dioxypyrimidine, right? Now, if you look at it, if you are numbering your purine ring, your pyrimidine ring, where is my 1? Is it here or here? 1, right? So 1, then am I going like this or like this? Yes. 1, 2, I'm going clockwise. 3, 4, 5, 6, right? Now, as you can see, the oxy group, some carbon 2 and carbon 4, right? That is why we said 2,4-dioxypyrimidine. For our thymine, this is my thymine. Thymine, we said 2,4-dioxy-5-methylpyrimidine. Because this 1, 2, 3, 4, 5, 6. So 2,4-dioxy-5-methyl, the methyl group is on position 5. 5-methylpyrimidine. For our cytosine, 2-oxy, because it's on position 2, 4-aminopyrimidine. Then for our orotic acid, 2,4-dioxy, 6-carboxypyrimidine. These are orotic acid. Now, it is very important that you know their structures. And have you written this? Yes. Now, to a simple way of knowing how to draw this. Okay, a simple way of knowing how to draw this is this. Let's say you want to draw your purine. Purine, you already know that purine is fused ring, right? You use carbon, 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 nitrogen, carbon, nitrogen, carbon. Look up, carbon, 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 nitrogen, carbon, nitrogen, carbon. You've gotten the 6-membered ring. Then the next thing, nitrogen, carbon, nitrogen, carbon. Just start with your carbon, carbon, carbon. After your carbon, 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 then you interchange nitrogen, carbon, nitrogen, carbon, like that. So carbon, 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 nitrogen, carbon, nitrogen, carbon. Come back here, nitrogen, carbon, nitrogen, carbon. And you know the type of double bond found there, conjugate double bond. That is, if I put one double bond, I give one space, give one double bond, one space, one double bond. Same thing here, I give one space, one double bond. I cannot put here because double bond is here. This is my purine. If I'm numbering my purine, this is my nitrogen 1. And I number it like this. I number the 6-membered ring before the 5-membered ring. So 1, 2, 3, 4, 5, 6. Then I come back here, 7, 8, 9. Right? Now, if I want to draw my pyrimidine, pyrimidine is how many membered ring? 6-membered ring, right? Just a single ring, is it not? I still do my carbon, 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 nitrogen, carbon, nitrogen, carbon. Carbon, 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 nitrogen, carbon, nitrogen, carbon. Then my double bonds. I give one space. I give one space. If I'm numbering my pyrimidine, where do I start from? Here, right? Yes. And I'm going clockwise. So 1, 2, 3, 4, 5, 6. These numberings are constant. If you start from here, you are wrong. Anywhere you start from other than this place, you are wrong. If you start from here and go like this, you are wrong. Do we get? Now, this is our purine. This is our pyrimidine. Now, these are purine, these are pyrimidine. If you want to draw adenine, once you know their backbone, to draw other ones are very simple. If you want to draw your adenine, just draw this backbone and attach your methyl group, your amino group. That's all. That's adenine. That's adenine. If you want to draw guanine, bring this amino group here and put and you put your double bond oxygen here. This is my guanine. Which other one did you talk about? No, I mean okay, xanthine and hypoxanthine. Xanthine, you just remove from your guanine, you just remove the amino group here, right? You have your what? Hypoxanthine, is it not? Then for my xanthine, instead of amino group here, I put double bond oxygen here, right? I have my xanthine. Do you get? Now, for the pyrimidine, they are the simplest to draw. Now for the pyrimidine, all the pyrimidine have double bond oxygen here. Check all of them. They have double bond oxygen here on position 2. Now, if you add NH2, just like you did in adenine, what you have is what? Cytosine, right? If I remove this and I put double bond oxygen here, what do I have? Uracil, right? If I add a methyl group to this, what do I have? Thymine, right? Then the orotic acid, I will not add a methyl group here, but I will add what here? Carboxylic acid group, because it's an acid, orotic acid. This is how to draw them. If you can draw it, you can give the other names the systematic names. Any questions so far? So you know that nucleotide contains 3 things, what, and what? Nitrogenous base, pentose sugar, and what? Phosphate group. Now, if we keep the phosphate group aside, we have a what? Now, that's that for the nitrogenous base. What about the pentose? The pentose can either be, let me clean this. Hope we've written this right. Which one? But we've written this. Alright, now for the pentose, of course you know by now that word ending with "ose" in biochemistry is what? Sugar, right? Now, pentose means sugar with how many carbon? 5 carbon sugars. Now, the sugars in nucleic acid can either be ribose or what? Deoxyribose. Deoxyribose. Either ribose or deoxyribose. Now, ribose is the one found in what? RNA, right? Yes. What is RNA? Ribonucleic acid, right? Because it is called ribonucleic acid because it's nucleic acid containing ribose sugar. Deoxyribose is found in what? DNA. The full meaning is deoxyribonucleic acid, meaning nucleic acid containing deoxyribose sugar. Deoxyribose sugar. Do we get that? Now, I forgot to say that. Now, give me all the bases, all the main bases we have. Adenine, cytosine, uracil, thymine. Good. Now, out of all these bases, uracil is only found in what? RNA. Uracil is not found in DNA. It's only found in RNA. Thymine is only found in what? It's only found in DNA. Other ones can be found in anyone. But uracil is only in RNA. Thymine is only in DNA. Do you understand that? Now, take note of this also. You can write it down. Are you done with that? Let's look at nucleosides. We already know that nucleosides contains what and what? Only nitrogenous base and what? And pentose, right? If you add phosphate to a nucleoside, what do you have? Nucleotide. If you keep the phosphate group of nucleotide aside, what do you have? Nucleoside, right? Now, good. Now, for a nucleoside, we say nucleoside. Nucleoside is equal to what plus what? Nitrogenous base plus what? Plus pentose, right? Good. Now, if the nitrogenous base is, let's say, let's list all the nitrogenous bases here. Adenine, guanine, cytosine, uracil, thymine. These are the major ones, right? Okay, let's complete them. Hypoxanthine, xanthine, orotic acid, right? Is there any other one? All right, now, if the nitrogenous base is adenine, and you add a pentose sugar, let's say ribose, What will be the name? What will you call it? What will be the name of the nucleoside? What will be the name of the nucleoside? Adenosine, right? So adenosine is adenine and ribose. Adenosine is a nucleoside, is it not? Because it contains only adenine and what? Ribose, no phosphate group. If we add phosphate group, it's a nucleotide. Do we get? So adenosine is just adenine and ribose. Now, if we have guanine and ribose, what will you call it? Guanosine, right? Good. Now, notice what is going to happen now. If you have cytosine and ribose, what will you have? Cytidine, right? If you wanted to end with osine, you end up pronouncing cytosine. Do you get? Because here guanine and ribose gave us guanosine, here adenosine. If you wanted to say you end up with cytosine, which is a base. So cytosine and ribose will give us cytidine. Now, one thing you should notice, for the purines, the nucleosides of purines end with osine. The nucleosides of purines end with osine, while the nucleosides of pyrimidine end with idine. For the purines, osine, just like we are saying here, adenosine, guanosine. But for the pyrimidine, ends with idine. Now let's look at if it is uracil. Uracil plus ribose will give us what? You what? Uridine, right? Uridine. So you see it's ending with idine. Uridine. Now if it is thymine plus what? Plus what? Deoxyribose. Remember that thymine is found in DNA, right? And the sugar found in DNA is deoxyribose, not ribose. Is it not? That's why we say thymine plus deoxyribose. What will be the name of the nucleoside? Thymidine, right? If you say deoxythymidine, you are not wrong. Thymidine. So what I'm emphasizing on is for the purines, the nucleoside ends with osine, while for the pyrimidines, the nucleoside ends with what? Idine. Idine. Is it on? All right, for inosine, there's another one here, inosine. Inosine is hypoxanthine plus ribose will give us inosine. Hypoxanthine, remember we saw hypoxanthine here. Plus ribose will give us inosine. So now if we attach one phosphate, now look up. This adenosine, right? Adenosine, is it a nucleotide or a nucleoside? Nucleoside, right? If I attach one phosphate to adenosine, what will I have? Adenosine monophosphate, right? Adenosine monophosphate, is it a nucleoside or a nucleotide? Because there is a phosphate group, right? If I attach two phosphates, it's what? Adenosine diphosphate. If I attach another one, it's what? Adenosine triphosphate. That is how it is. So long as there is a phosphate group, you call it a nucleotide. But if there is no phosphate group, you call it a nucleoside. Now, we already know that nucleotide contains two things, right? Nucleoside contains two things, nitrogenous base and the sugar. Now, how are they attached together? First, we already know we have two types of pentos here, ribose and deoxyribose. Look at their structure. Ribose is how many carbon sugar? 5 carbon sugar, right?
Yes.
is a Purine ring. So you draw it this way. Now, if you can't, this one carbon, right? Carbon 1, 2, 3, 4. So we need to attach another carbon here, making it 5, right? Now, this is the structure of my ribose. This is the structure of my ribose. We want to see how we can attach the ribose and the base together to get our nucleoside. This is my ribose. Now, for deoxyribose, it's almost the same thing. In fact, the full name is 2'-deoxyribose, meaning deoxy, meaning removing what? Oxygen, right? 2'-deoxyribose means remove oxygen on carbon 2. So in deoxyribose, we are removing this oxygen here. So the only thing is, if I'm drawing the structure of deoxyribose, so if you notice, the only thing I did here was to remove this O, right? Here there's no O again. That's why we call it 2'-deoxyribose. 2 because if you are numbering this carbon 1, carbon 2, so it's on position 2. I'm removing that. Now, how do we attach this sugar and the base together to form our nucleoside? How do we do that? I'm going to start with the purine and we go to the pyrimidine. We already know how to do our purine, right? Carbon, 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 nitrogen, carbon, nitrogen, carbon. Then nitrogen, carbon, nitrogen, carbon. Is it not? So I'm going to use the general purine. General, let me not be specific. Let me not use any particular one for now. Now, if you want to attach this to ribose, we said for the purine, the carbon 1, this is my carbon 1, right? Carbon 1 of the sugar is attached to the purine on nitrogen what? Nitrogen 9. Remember, if you are numbering this is my what? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? This is my nitrogen 9. So it is this, there's H here. It is this nitrogen 9 and carbon 1 that will condense together. Now let me draw this here and we'll see how they join together. Now look at this. Look at this. It's a condensation reaction. Water is going out, is it not? Yes. So OH is taking H, right? Now, the only thing you do here is to remove this whole stuff and join it together. That's all. You just join this one, remove the OH and the H, and you join the two together. Water is going out. Do we get that? Yes, sir. There was hydrogen here, and there was OH here. Water is HOH, H2O, is it not? So this H takes this OH, and that is out. You join the two together. Now, with this is my nucleoside, right? Yes, sir. This is my nucleoside. If you see carbon 1, the OH on carbon 1 join the nitrogen 9, right? For a purine. Now, for the pyrimidine, if I'm drawing my pyrimidine, carbon, 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 nitrogen, carbon, nitrogen, carbon. The more you say this as you are drawing it, the more it sticks. Carbon, 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 nitrogen, carbon, nitrogen, carbon. You can never forget it in your lifetime. Now, we know all the pyrimidine, all the pyrimidine have double bond oxygen here, right? Good. Now, if I'm numbering this, where is my nitrogen 1? Is it here or here? Here, right? So 1, 2, 3, 4, 5, 6. Right? Now, where am I attaching the sugar to? Nitrogen what? Nitrogen 1. This one was nitrogen 9. But I'm attaching it to nitrogen 1, right? So the same thing, let me draw my ribose. Now this H takes this OH as usual and the bond joins. This is my nucleoside also. So as you can see here, this carbon 9 and this is nitrogen 9 and this is nitrogen 1. You draw these things. So take note, and they are actually very simple. So this is how you connect your... Now what if you want to make it a nucleotide? Remember, what differentiates a nucleotide from a nucleoside is the presence of what? Phosphate group, right? Now, if you notice, this is my carbon 5, right? Your phosphate group is always attached on carbon 5. For example, this is, if I write my OH here, is the same thing, right? Now, if I join a phosphate group here, this is my nucleotide, right? If I can keep on adding phosphate. If I add one phosphate, monophosphate. If I add another phosphate, diphosphate. Add another phosphate, triphosphate, just like that. So I want to believe we know how to draw them now. Now, what we are going to actually do, since we've gotten this background knowledge, is how do we biosynthesize this? How is this synthesized in our system? It's actually very simple. If you can draw this. So put this down. So you can put here purine nucleoside, here pyrimidine nucleoside.